Alright, g'day guys. I'm going to talk to you quickly about how to analyze the data that we've collected from our auditory versus visual test. Hopefully you conducted it, you're honest, you put it into the Microsoft form, your teachers then download that for the whole year group, put it into the content library, and you now have an Excel file in front of you. Yours won't look like mine because mine I collected from the teachers. But it will be essentially the same sorts of data and the same columns and stuff. Now, the first thing you need to do when you're looking at data, let's just get my noggin a little bit smaller, is look for any sort of anomalies and strange things in data. Excel doesn't like that non-numerical values. So somebody in the Microsoft form must put milliseconds. I'll just delete those milliseconds, turn it back into a value. I'm missing a value down there. There's not much I can do about that. I don't really like these long titles, so I'm going to change them just to reaction time and auditory reaction time. These are very wide, so I'm going to double click on the column widths to make them smaller. Okay, so now I've got this little issue where this one is, oh, no, I did that. This one here is, oh, it's done it again. Now I'm going to make it a bit wider so I can put my cursor in there. Is in milliseconds. Oh no, sorry, this one is in seconds. Okay, and over here, this one is in milliseconds. All right, so I can't really compare them if they're not in the same unit. So what I'm going to do is I'm going to put a new column here. So let's take that, Control C, Control V to cut and paste, and I'm going to change that to milliseconds. Okay, how do I convert seconds to milliseconds? Well, there's 1,000 milliseconds in a second, so therefore to do that I'm just going to say I'm going to do a calculation equals, I start a calculation in Excel, and I want to take my number of seconds and I want to multiply it by 1,000 to get it into milliseconds. Okay, so now I can see I've got milliseconds here, which look more coherent with the auditory reaction time. Now I'm going to I'll do that again. See this little green box down the bottom of the square? I'll take that and I will drag it all the way down to replicate that same calculation for every one of them. So now I've got two columns, auditory and visual, which are in both in milliseconds. So now it's easier to compare. Okay, so when we're doing science, what we really like is we like means, okay? So we like mean values. So how am I going to get a mean? I might just take those two again, Control C, and I put them over here. And I'm going to calculate the average essentially for my auditory and for my visual. So a mean is just the number of the addition of all the samples divided by the average. Fortunately, Excel has a little function to save a bit of time here. Say equals. If you start typing average, you'll see it gives you all these different calculations you can do. I'm going to click on average, double click it, and then it opens up brackets. Then I select the data that I want to find the average of, and then I'll close my bracket. And Bob's your uncle, you've got an average for the auditory. Now, Excel is clever. If I take that little square and I drag that across, it's going to recognize that it doesn't want to do the same calculation again on the same data. It wants to do it on the new data. So if I were to just look at the calculation up here, you can see now it's finding the average of the visual. So now I have the auditory and the visual. So in Excel, you can do the calculation once, and then often you can drag it across, and it knows what you want to do. It's very clever. So they're the means. What about the number of samples? Okay, so sample number, often represented by just n in statistics. So how many samples? Well, there's another calculation to do, equals, and I'm going to do a count. So count. Just type count, double click the count, it opens up the brackets, and I want to count how many samples I have. Okay, okay, so G2 to G40, close brackets, press enter, and it's saying I have 38 on there. Now, I can see there's one missing here, whereas there's none missing here. So hopefully, if I do that same count on the visual, I'm going to end up with, so let's have a look, visual, and you can see there's one more sample number. That makes sense because we're missing one. Somebody didn't enter it for their auditory. Now, okay, so now we know the average and we know how many samples we took, but in science, we want to know what the spread of the data, like is the sort of spread of the auditory data the same as the spread of the visual. But before I do that, I might just get an idea for what my data looks like. So I'm going to graph the means of my auditory reaction time versus my visual reaction time. So I just highlighted it plus the titles, and I'm going to say insert, and I want to insert a column graph. This is discrete data, meaning what people get for their auditory reaction time isn't necessarily, I mean, it probably is somewhat related, but it's a line graph is definitely not the right type of graph to do here. They're kind of discrete from one another. They're independent. Okay, so here I can see that, like this chart alone, so I can just say mean reaction time. Also, if you want to change things on the chart, because I don't have, I may as well fix it up now. Double click on the chart, and then up here in the top left hand, you'll see it's a add chart element, and I actually want to add an axis title. So it's one over here, and I'm going to say reaction time, and I'm going to put milliseconds, the unit, always put the unit, okay? Reaction time, milliseconds. Okay, perfect. Okay, so straight away, looking at this, one would say, oh, look at that, auditory reaction time is much faster than visual reaction time. But really, you can see that the axis starts at 322, so really, is that difference actually all that significant? In science, we need to add error bars to really see whether there is a significant difference between these two averages. At the moment, if I just looked at that and somebody put that, I'd say, oh yeah, visual, much slower than auditory. But in science, we need to be more confident in that. We need to do some more statistical tests. So what do? First of all, let's work out how spread out our data is. So like, is the spread of data in auditory much larger than the spread of data in visual? People tend to get much closer to the same average in visual, or is it that the case for auditory? So what we do is we do a called standard deviation. So how much do the values deviate from the mean? That kind of is what it's looking for. So to get standard deviation, you can just say equals, once again, start typing ST. We want standard deviation of the sample that we've taken. So I'm going to double click on standard dev S, and I'm going to choose all my values, going to close brackets, press enter, and there's my standard deviation. Now, once again, I don't need to replicate, I can just drag that across, and just to show you that now it's done that, the visual has done that for the visual, okay? So, standard deviation is interesting, it's good, it tells us the spread of the data, and I can see that people tend to get closer around the mean for visual than they do auditory. There was a much larger deviation. People were kind of fluctuated much more from one another in terms of the auditory. And I kind of, even when I tested this and did one for one, I found the auditory was probably a little bit more fluctuated for me on a personal level. That's very anecdotal. But now let's look at the standard error. Now, standard error is a really important calculation in science. We don't know what the true value for auditory reaction time and visual reaction time is. It's not something you can necessarily look up. So we got to imagine if we replicate this test for every single person on the whole planet, then and found the average, we'll know what the exact average is, but we're never going to be able to do that. So instead, we use this statistical test called standard error, and it's what standard error is. So it tells us the more tests you do, the more replications you do of your experiment, the smaller your standard error becomes, the closer you get to the true value. So this is really important. It's why you need to do lots of replication. People say, "Oh, I did 3 replications of my experiment." No, that's not enough. It's not very good at all. You need, in science, we need to do tons of replication. Like straight away, you can see that I've already collected 40 here. We want you, when you do your experiment, to do lots of replication. That's the only way you can be sure of your results. Okay, so standard deviation. Oops, sorry, not standard deviation. We're now doing standard error. So how close are we to what we think is a true value? So how do you do that? Excel doesn't have a proper calculation for this. We need to put it in. So standard error is the standard deviation. So I click on standard deviation, K4, and I divide it by the square root. So SQRT, that is a square root in Excel, the square root of the number of samples. Now let's just think about that. Let's imagine I took 1 million samples. What's the square root of 1 million? It's still a pretty big number. Whereas what is the square root of 38? It's much smaller. So if I took 1 million samples and I divided the standard deviation by a really big number, I'm going to end up with a really small number. Whereas if I have hardly any values, let's say I only have 1. Let's say I have 1 sample. And so the square root of 1 is 1. So therefore, my standard deviation would be the same as my standard error. So the more samples you take, the smaller your standard error becomes, the more reliable, or the more accurate, I should say, your experiment becomes. So let's close that and press enter. Okay, and I'm going to replicate that whole thing for visual reaction time. So I can see that in terms of standard error, I'm a little bit more confident, a little bit more accurate with a visual than there was with the auditory. It's a small standard error. Now, we need to add these error bars, because this is meaningless at the moment with just averages. We need to add error bars to this graph. Okay, so how do we do that? There's 2 ways. If you double click on your graph, you can say add chart element. Okay, so I think if you're a Mac user, you have to do that. But if you've got a PC, there's a little button here. You can click that, and you click down this little arrow that says error bars. Okay, we want more options. Okay, and I'll bring this stuff up over here. Well, I might do that again because it hasn't actually. Error bars, more options. There we go. This is what we want. Okay, and I want my error bars to go above and below. So at the moment, it's just got a fixed value error amount. That's not what we want. I actually calculated the proper error that can go onto these, so I want to put them in. So I want to put custom. Okay, so I'm going to specify the values. Okay, and my standard error. So I click this little arrow here, and I want to choose my standard error. Okay, and that's for my positive to go above, and I want the same standard error to go below. Okay, I don't know, it should appear there, I don't know what's on my computer, but anyway, I do that, and now I can see that it's put in the 2 standard. They're very similar, I mean, they're very close numbers, but you can see now, like if we were to then, this is a graph, I would put this graph in my report 100%. It is a really valuable graph, and I might do a little bit of description underneath, but really what it's telling me is that although visual is slower, took longer than auditory, the error in the 2 of them overlapped so significantly that I cannot be 100% sure. In fact, I can't be very sure at all that auditory is in fact faster. It could just be that the sample I took, the people I took, happened to have auditory. If I tested more and more people, the smaller my error would get, and the more confident I could be that auditory is faster than visual. But at the moment, if my hypothesis was that auditory is faster, I would have to reject it. I would say I cannot be confident. More testing is needed, more sample sizes are needed. Okay, so I want you guys to try and replicate that process for the student data that you're going to have in your content library. Okay, so good luck. Post questions to me or to any of your teachers if you have any questions about how to do this. See you guys.